So we have our next set of notes. We should be on page 47, and again, we should be taking notes as we watch this video. Feel free to pause it if you need to. And these notes will be on the intermediate value theorem. A theorem in math is basically a rule, kind of like a law. It's a rule that can be proven by a bunch of different facts. And we'll have a few theorems in calculus. The intermediate value theorem is the first of those. So we're going to just kind of write this theorem out, and then we'll go over what it means. So all right, if f of x is continuous on a to b, and I want you to leave a little bit of space over here on the right, so we're going to just go down to the next line, and f of a is less than y, which is less than f of b, then there must exist at least one value, we're going to call that value x equals c, such that, or you could say where, f of x, or we'll start, say f of c equals that y value for a is less than c is less than b. You could say on, the interval from a to b could work as well. Okay, so that seems like a lot. It seems really kind of scary and crazy. It's really honestly super easy. Okay, here's just kind of a thought process. If I asked you to count from 1 to 10 by ones, would you have to go through the number 6? Yes. Why? Because 6 is in between 1 and 10. Would you have to go through the number 13? No. Why not? 13 is not in between 1 and 10. That's all this theorem is saying. Another thought would basically be, if I told you that we were standing in the classroom and I lined all of us up on tiles, right? And then maybe we had some more tiles. Okay. And maybe you were standing right here on this tile, and another friend was standing here, and I threw a chair in the middle here, and then maybe I am standing over here. Okay, so in order for you, if you can only walk in a straight line, in order for you to go, give your friend a high five, would you have to pass through the chair? Yes, you would. Right? Why? It's in your way within that straight line. Would you need to pass through me? No. So that's all the intermediate value theorem is saying. It's honestly super, super easy. So if we kind of think of this graphically, what we can do is just kind of draw a graph here. And I'm going to put an A value and a B value. And it actually doesn't really matter this, we can kind of put a little asterisk here. It doesn't matter if f of a is smaller or bigger. This could be backwards. So f of a could be our bigger value. F of b could be some smaller value. But if this graph, here's the big thing, if this graph is continuous. So if this graph is continuous, it doesn't matter what it does as long as it's continuous, right? If we have, we're going to call basically over here, this y value is going to be f of a, and this y value here is going to be f of b. So if we have some value that we're going to call y, right, and y is in between it, right? Y is in between f of a and f of b. Then my graph must pass through that y at least one time, and we call that point our c. And that's all this is saying, right? Another thought is basically, if I know that I have one negative value and one positive value, and I know that this graph is continuous, well then somewhere I'm going to need to pass through 0. And that's what the intermediate value theorem is basically saying. So if you have a highlighter, you could go ahead and highlight this. This is our if condition, so this must be true. If f of x is continuous, right? And the big thing here again is that word continuous, right? That's the big one. So if f of x is continuous on that closed interval from a to b, and second part is if there's some y value that's in between my two endpoints, right? Again, this doesn't really matter if these are flipped. It doesn't matter if the first endpoint is bigger or the second point is bigger. It's basically saying there's some new value that's in between our endpoints. Then there must exist one value of x equals c. So the next part is the then, right? So the then part is the result, right? What is the result? There has to be some value c where f of c is equal to y in between a and b, right? That's key, in between a and b. So it's saying, if I have, again, if we go back up here, right? If I have a negative value here, a positive value over here, somewhere in the middle of those two, right, like in between those two, we have to cross through 0. Now, it could cross through 0 again, right? We could go over here, but this point is not guaranteed by the mean value theorem. What's guaranteed by the mean value theorem is that basically at least one time in this section of my graph, right, in between here, at least one time, the graph must pass through 0 because I had a negative y value and a positive y value. Super easy. Some of the questions will get a little bit more complicated, but that's all it boils down to. So investigating these graphs, we're going to kind of determine, is this theorem applicable for these functions on the specified intervals for that value that we're given? So is there a value of c in between -5 and 2 where f of c is equal to 2? So this is kind of key here, in between -5 and 2. So here's -5, and then +2 is over here. So is there any time where f of c is equal to 2? Right? If I kind of look here, there actually is, right? Right here, we pass through 2. I'm going to actually say yes. Now, does IVT guarantee that that had to have happened? And the answer here is no. Why not? No, because f of x is not continuous on the interval from -5 to 2. Right? We got this jump here, right? We could say, f of x is not continuous, specifically, not continuous at x equals -2. Now, I am going to kind of say one quick little caveat is later on, as you get more and more advanced, technically there's something called sandwiching. And what a sandwich would be is, if we kind of looked right here, if I looked -5, right, my y value is 0. Then at 3, my y value is 4, -3. Now, is the graph continuous in between -5 and -3? Yes, right? So in this little kind of sandwiched off section, f of x is continuous here. And does, basically if I look at my y values, I have 0 and 4. Is the y value of 2 in between 0 and 4? Yes, it is. So basically the mean value theorem actually would be guaranteed here in between -5 and -3. And that is part of this interval. So actually, by kind of a technicality, we could say yes. I'm going to kind of just put a little asterisk here. We technically could say yes, IVT guarantees a value of f of c equal to 2 for the interval, or for a c such that st is such that -5 is less than c, which is less than, we said, -3. Right, so in between there. This is a little bit advanced, I could throw that as an extra credit. Okay, now looking on the second one, same graph, but now we want to say, is there a value of c in between -1 and 5? So if I look at -1 and 5, is there a time where we pass through 2? And if we look, no, there's not. Did IVT guarantee this? Well, why or why not? So let's kind of look at my endpoints. What's my endpoint for f of -1? Now, and the reason I'm doing this, and I didn't do it over here, is what was my first thought? My first thought is f of x continuous? Well, in this first one, my answer was no, f of x wasn't continuous, so I just stopped. In this case, f of x is continuous. So kind of that first rule, I guess, f of x is continuous for -1 to 5. That's the first thing we want to check. right? So in this case, my first rule was no. Okay, so then my second rule is, we know IVT can apply, but my second rule is what are my endpoints? So f of -1, right, that endpoint here is -0.5, right? The slope is down 1 over 2. Then f of +5, again, my slope is down 1, right 2, so this is going to be -3.5. Well, the problem is that 2 is not in between those values. So we're going to say that, basically 2 is not between f of -1 and f of 5. Therefore, IVT does not apply. So what two conditions must be true, right? We've kind of gone through this. F of x must be continuous for our interval from a to b. And then the second rule is that f of a must be less than our y value that we're looking for, which must be less than f of b. If you want to, you can kind of put, or f of b must be less than y, which must be less than f of a. Basically, this is just backwards, right? It's basically saying that our y value must be in between the two endpoints. So for these problems, this is kind of how the homework might look, is we're going to be given a function and then an interval and a c value. So we have f of x, and in this case, where is this graph not continuous? So graphs are not continuous. What we need to know, kind of right now, is graphs are not continuous at holes, at vertical asymptotes. Those are the big ones. If we have a square root that's negative. So in this case, wherever our denominator is 0, it's going to be not continuous. So we know this graph basically is f of x is not continuous at x equals -2, right? X plus 2 equals 0, so at x equals -2. Now, is -2 in between that interval? It's actually not, right? -1, 0, 1, 2, 3, and that's my interval, right? All the decimals in between them, but -2 is out here. So actually, this graph is continuous between -1 and 3. So for that first rule, we're going to say, yes, f of x is continuous for -1 to 3. So we can go on and check our second rule. So our second rule is we're going to look at the endpoints. So f of -1, I'll plug that in. It's going to be -1 minus 3 for -1 plus 2. It's -4 over 1. It's -4. Then I'm going to check my other endpoint, f of +3. 3 minus 3 gives me 0 over 3 plus 2. 0 over 5 is 0. All right, 0 in the numerator is 0. 0 in the denominator would be dne. So is 2/3 in between those two numbers? Well, it's not, right? -4 is negative number, positive 2/3 is positive. So we're going to say something like, -2/3 is not between f of -1 equals -4 and f of 3 equals 0. Therefore, IVT does not apply. So even though we had a continuous graph for our interval, IVT doesn't apply because the y value wasn't in between the two endpoints. So we got to check both of those. All right, for our second one, we still have the same graph, so we're still going to basically know that x can't be equal to -2. Now this time -2 is between -4 and 1. So we're going to just kind of stop at the first rule. We're going to just say f of x is not continuous at x equals -2. So f of x is not continuous on the interval. You'd also say 4. It's a little bit easier sometimes, -4 to 1. Therefore, IVT does not apply. So you can just stop right there. As soon as one of those two rules fails, you just say IVT does not apply. All right, next one, we have p of x equals e to the x plus 2 times cosine of x. And this one actually is kind of a calculator question, so I'm going to just throw an explanation for what you would type into your calculator. But let's go ahead and start this off first. So what we would kind of think about is, e to the x is a continuous graph and cosine of x is a continuous graph. So if you kind of combine both of those, we'll get a continuous graph. And what you can kind of do is you can do the first rule, right? We can say that p of x is continuous. Then you can do the second rule, and then you can say that what is p of negative 2 and what is p of positive 1. And you would basically have to type those into your calculator and you would get decimals. So I'm actually going to pop over here to where I've done this before and kind of show this. And so we would have this p of x is continuous. P of negative 2, I got the decimal negative 0.4161. P of 1, I got 10.8523. And so p of c is equal to 5. That's what they're looking for, is in between those 2 points. So then we would say, therefore, IVT does apply. And if we want to be able to solve this, right, we would want to set the equation e to the x plus 2 times cosine of x equal to 5. You can do that on your calculator. We haven't learned how to do that yet, but we can do that on our calculator, and I'll show you guys in class next week sometime. So what I kind of want to do instead of that is not really worry too much about this one. If you have some room here still, you didn't copy all that down, you can do this here. Otherwise, you can use a scratch sheet of paper or one of the back pages, squeeze this in maybe at the bottom, right? But what I want to kind of talk about is let's just actually go back to this guy up here, but let's do a new point. So let's do something like this. Let's do the same equation, f of x equals x minus 3 divided by x plus 2. Let's do on the interval from negative 1 to, from negative 1 to 8. And we want to say for f of c equals to 0. Okay, so let's kind of do this one as a replacement 3. You could call it number 4 if you want to. Okay, so this will be our question. So the first part would be, this should be a bracket. Okay, the first part is that continuous part. So remember, f of x is going to be continuous here for negative 1 to 8. And the reason it is continuous is that we couldn't have x equals negative 2, but that is not in that interval. So in the second thing we're going to check is we're going to check our endpoints. So f of negative 1, we should plug this one in the first part. Negative 1 minus 3 over negative 1 plus 2 gives me negative 4 over 1, which is negative 4. Then f of 8, we'll plug that in, 8 minus 3 over 8 plus 2. It's going to give us 5 over 10, which is 1/2 or 0.5. So now this time, 0 is in between those 2 points. So we can say something like this, is f of negative 1 is less than 0, which is less than f of 8. Right? You'd also say, negative 4 is less than 0, which is less than 1/2. Right? So we're going to say, therefore, IVT applies. And if they just ask us, is it guaranteed? Is there guaranteed, like must there be a value? We could stop here. In this question, though, they actually said, if it is applicable, we want us to find that value c. So in order to find that value c, what we'd basically do is we would just take 0, and we would set it equal to our equation. So we'd say x minus 3 divided by x plus 2 must equal 0. Well, if I multiply both sides by x plus 2, right, 0 times anything is 0, so I'm just going to get x minus 3 equals to 0. It's kind of a shortcut. When you do these, you can just set the numerator to 0. So then you just add 3 to both sides, and you get x equals 3. That's my value for c. You actually may, rewrite this as c equals 3, and that's your answer. Looking at a few more, we have number 4, x divided by x minus 2 on the interval from negative 1 to 1, for c is equal to negative 1/2. So we want to have, in this case, where does this not work? This does not work at x equals 2. 2 is not in there. So we can say for our first rule, f of x is continuous for negative 1 to 1, right? We're checking where does this graph have a vertical asymptote, and it's between negative 1 and 1. We have 2. That's not in between negative 1 and 1. So we are continuous. Second rule, we just plug in our endpoints. F of negative 1 equals negative 1 over negative 1 minus 2. That's negative 1 over negative 3, which is 1/3, 0.33. And then our other endpoint, f of positive 1 equals 1 over 1 minus 2. That's 1 over negative 1, which is negative 1. So negative 0.5 would be in between those values, right? If you're not really sure, make a number line. Use decimals, right? We have 0, we have negative 1, we have positive 1. So we have basically like 0.33. And then we have negative 1. This is our section that we're looking for. And we want to know, is negative 1/2 in between there? Well, it is. So what we can say is something like this. The smaller value is the negative 1 value. So negative 1 is less than negative 1/2. That's the value we want, which is less than 1/3, the middle value. Right? This always has to be in the middle. Right? You could also say f of 1 is less than negative 1/2, which is less than f of negative 1. Right? This is the y values. Okay. So we're going to say, therefore, IVT applies. And again, they want us to solve for that value of c. So we're going to set negative 1/2 equal to x over x minus 2. So x over x minus 2 equals negative 1/2. If you want to, you can actually even change these to c's since we're going to be solving for c. And you can just cross multiply or butterfly method. So c times 2 is 2c equals negative 1 times c minus 2. Distribute that. Make sure you use parentheses. 2c equals negative c plus 2. Add the c over. 3c equals to 2. Divide by 3. So c is equal to 2/3. All right. And then there's one more question. This is a calculator question. I'm not going to worry about this one so much. I'll show it to you guys next week when we have our calculators. It's similar to what number 3 would look like. If you really want to see it, I can show you over here. Basically, f of x is continuous. This is an exponential function, right? Exponential functions are pretty much always continuous. Then, oh, you know what? It looks like we don't need a calculator here. So you could copy this down if you want to. F of 3, when we plug in 3, we get negative 1/2 to the 0th power. Negative 1/2 to the 0th power is just 1, and then minus 2. So 1 minus 2 is negative 3. Then we will plug in f of 5. And when we plug in f of 5, we're going to get negative 1/2 to the negative 2nd power minus 2. That negative exponent is going to flip our 1/2 to 2 over 1. So 2 squared is 4. So this is going to give us negative 4 minus 2, which is negative 6. And then negative 4 is in between those 2 points, so IVT applies. Then to solve for our value, we're going to set that equation equal to negative 4, add 2 to both sides. This part's a little bit weird, but in order to solve for that exponent, we're going to take the ln of both sides. You can bring the exponent down in front, so you divide by 1/2. So we get negative x plus 3 equals ln of 2 divided by ln of 1/2. Negative x equals ln of 2 over ln of 1/2 minus 3. The solving of this is a little bit weird. Divide everything by the negative, and we'll get this answer here on the left. Negative ln of 2 divided by ln of 1/2 plus 3. There is a little bit of weird math that goes on where if you solve this, you're going to actually end up getting 4. And it has to do with the fact that ln of 1/2 is equal to negative ln of 2. I'll go over that later. If you type this all into a calculator, it'll give you 4. And again, I'll go over this later. I'm not going to ask you this question on the quiz or a test. This is a little bit more advanced. Okay. So for homework, we're going to be asked to determine, using the intermediate value theorem, if the function has a 0. So basically, if we want to know, does this function, like if the function has a 0, right? For IVT, and actually you could come back up here to your notes, a big question, a big kind of hint is this kind of must there be is a really big, whenever you see must there be, that's a big hint that we're going to be using one of the theorems, possibly IVT, right? And if they just ask, is there a function, is there a value where this happens, that could also be. So they're basically asking, is there a value where we have a 0? So, the first step is going to be to check, is this function continuous? Okay. And then the second, if it is, you're going to plug in f of 0, you're going to plug in f of 1. If you get one answer that's negative, one answer that's positive, then yes, there must be a value. And it says justify your answer, and if it does exist, find that 0. So if it does exist, you'll set 0 equal to that function. Okay. Before I move on, I do want to kind of point this out, and we can add this to the bottom of our notes, is when we're talking about continuity. Okay, is a graph continuous? If you're not sure how to know this, the first big thing you want to look at is there a denominator? So anytime you have a denominator, right, you have a numerator and denominator, wherever this denominator equals to 0, our graph will not be continuous. Okay. The second thing we can look at is, do we have a radical? So anytime you have a radical, what's going to happen is this radical must be greater than or equal to 0. So basically, if we kind of take the opposite of that, anytime that radical, whatever's inside of your radical, is less than 0, we will not be continuous. Now, if we have a exponentials, right, like e to the x, 3 to the x, anything like that, and polynomials, we don't have to worry about this, like x cubed plus 1, x squared plus 2x minus 8. These guys are awesome because these guys are pretty much always continuous. Same thing with sine theta and cosine theta. Okay, so sine theta, cosine theta, always continuous. Now, if you get something like this, sine of 1 over x, this part does have a denominator. So x cannot be 0, right? Because the bottom can't be 0. That's a little more complicated, but these are the two main things we want to focus on right now. Okay. Later on, we'll also worry about ln's, right? The inside of an ln is very similar to a radical, right? This inside part has to be greater than 0. It's almost the same as the radical. We're not going to worry about that too much yet, but that's one of the other rules. And then another rule we could have is tangents, right? So the inside of a tangent, this inside cannot be like an odd, it's kind of weird, but an odd multiple of pi over 2, right? And that's because at 0, tangent of 0 is 0, but tangent of pi over 2 is undefined. And it's a little bit weird. We don't really need to worry about that stuff too much. Okay, so on number 2, when we're looking at this, we have theta squared. You could kind of treat this as x squared if you want to do like x squared minus 2 minus cosine of x. Well, x squared minus 2, that's a polynomial. That's always continuous. And then cosine of x is always continuous. So this graph will be continuous everywhere. So for that first rule, we're going to have it continuous. Then the second rule, you're going to plug in 0, you're going to plug in pi, and you're going to see again, is 0 in between those numbers? So basically, is there a negative number? Is there a positive number? For exercises 3 to 5, we're doing the exact same thing. Okay, we're first off finding, is this graph continuous? This polynomial should be easy. And secondly, we're going to do f of 0 and f of 3. And we want to know, is the value 0 in between those? If it is, we're going to say yes, IVT is guaranteed. If it's not, we're going to say no. And if it is, we're going to solve for it. We're going to set 0 equal to that. Number 4, same thing, but now we're looking at 4. So is this graph continuous? It's a polynomial. Should be easy. Yes, it is. Secondly, find g of 0, find g of 3, and then you're going to check, is 4 in between those values? If it is, you're going to say yes, IVT works. If it's not, you're going to say no, IVT doesn't work. You're going to stop. Number 5, we're going to figure out where is this interval continuous. So you're going to set the denominator equal to 0, and you're going to check, is that in between there? If it's not, you're going to say no, IVT doesn't work. It's not continuous. If it is, you're going to move on. You're going to do h of 5/2. You can use your calculator, get a decimal, and then h of 4, and then you're going to figure out, is 6 in between there? And if it is, then you'll solve for it. Okay? And then that's it for this homework. So hopefully that helps. Email me or write a comment on Google Classroom if you have any questions. And this was still a long video, but a little bit shorter. You still should have about 20 minutes left of class if you started this video at the very beginning of class, so you can start your homework and get a head start on that. Reminder, the quiz is on Monday. The quiz is basically going to be go over days 1 through 7 homeworks. So go ahead and take a look at those. You should also have some answer keys on Google Classroom to look at. And I will see you guys back in class on Monday.